Okay, for today, we're going to be starting with a little quiz, and I've got to move this point over just a little bit. Let's say that this is 1, 4. This point right here is 6, let me think, if that's 4, this must be more like 10, 10. Okay, and then let's say this spot here is -6, 7. Okay, can you name an area where this graph is decreasing? You got to be able to say decreasing. Well, it's like you can't just point to it and say, well, it's decreasing in here, Mr. Server. Well, that's great, but can you say it in math? All right. Raise your hand if you're confident you'd be able to say this right. Okay, good. Gio, want to give it a shot?
It's decreasing -6 to 1.
-6 to 1. And you can use parentheses or brackets in theory on this. I would use parentheses, just to keep your life simpler. Okay. And is it ever increasing? Well, yeah. There's more than one place, in fact. Everybody write down the 2 places that it's increasing. You might be thinking, well, I only see one place. No, at the very beginning of the graph was increasing. And how do you say that it's always been increasing at the beginning until it hits a certain spot? All right, so you should have said that it was increasing in this zone here, which would be from -infinity up until it hits -6, parentheses. Then you could also say that it was increasing in this zone right here, which would have been from 1 to 10. I know there's a funky looking 10 right there, but from 1 to 10. And if you put them right next to each other, this would be unioned with that to say that's the place where it is increasing. That make sense to you? Yes?
So for the decreasing, you have to put the second one too at the end?
Okay, so if I was going to leave the last decreasing one, that's everybody write the right way to say that decreasing interval at the end. And yeah, you would say union between this one and the other one. So let's write that last interval right here. You want to tell me what it is? 10 to -infinity? No, such an easy mistake to make. Let's talk that through. What we're not talking about is not talking about how high or low this thing is going. We're using x values. So as I'm saying it's going that way, that's not -infinity. It's about that way. Okay? I know it ends up really low, but that's not the point. We knew it was decreasing. And it's not a range. If it was a range, you'd use -infinity. 10 to a regular infinity, yes. Because it's this direction here that we're going. Okay? These are x values. All right. So that's just a brief reminder of some of the things you're supposed to know. That one got a little messy, so I'm going to just make another one here and say that this is 6, 7. I also liked having 2 numbers for that spot instead of just the same number repeated. And let's say this is -3, 5. And last but not least, let's say that's 1, 3 is this spot. So my question, what's the local minimums and maximums? Write them down, name them. And if there is any absolute maximums or absolute minimums, name them. So let's talk about mins and maxes here. Okay, so you should have said that this was a local max and this is a local max. And you might be like, no, Mr. Server, you're wrong. It's an absolute max. No, I wasn't wrong. It's a local max. And it's an absolute max. It's both. Okay? You can be both. What's this? Say it. Look them in. All right, is there an absolute min? No. And you should not say, yeah, it's negative infinity. Nope. That implies there's a low spot. And what do you really have to have a minimum? You can't just be going down and like, well, that's the end. No, it's going down forever. So to have a low spot, you can't just have like a little glitch and then it keeps going down. That wouldn't be a local min. Know why? Because you have to have a spot. If it's going to be a low spot, then you have to have spots on both sides of you that are higher than you are. Do you get what I mean by that? So like, is this a low spot? No. If it were just low enough to make a low spot, it would have to have spots on both sides that were higher than this blue spot. Maybe we should make it black. This black spot right there. Let's try making it actually black instead of gray. There. Now it's a low spot because there's spots on both sides of it that are higher than it. Okay, so does this have spots on both sides of it that are higher than it? No. So that's not a local min. All right. And it's definitely not the absolute min because there's stuff lower than it. So this would have no absolute min. All right, good enough on that. I think it's time to take that quiz. So everybody start that Schoology quiz. And we'll resume the lesson again a bit after they're done with their quiz. Okay, so for today we took that quiz and now we're going to go back and do more of these kinds of questions. But we're not going to do them just by you sketching them. Because I know you would know that this, pausing for a second. I know that you would know that this, if you haven't already got there, find the notes that have this page in them, is taking my function and it is making it half, in some way anyway. Is it vertically half or is it horizontally half? Vertically. I taught you high-vo. Horizontal if it's on the inside, vertical if it's on the outside. That's a vertical change. It's a vertical cut of a half. It's half as vertically high. Could you make this half as tall? Yeah, it'd be pretty easy actually. You just go half as tall, that's half as tall, that's half as tall, that's half as tall, and that's half as tall. Does that make sense to you? Okay. And then wait, what about the negative in front? What does that do? That makes it flip. Now this is the part that gets a little more concerning. It's going to be a vertical reflection, a flip. But I'd like to do this in terms of points. So everybody make a list of the x and y points of the original. So the first point is going to be this one. Can you guys tell me what point that is? Negative something, comma something. Help me out. Negative 7, comma 4. What's the next key point? Say it. Negative 4, comma 2. Good. Next one. Negative 1, comma 4. Good. Next one. 4, comma 6. Thank you. And the last one. I think it's 8, comma 2. Can anybody verify that? All right, good. Then, here's what you'd have to do. Since it's a vertical change, these guys are the horizontal. The x's are the horizontal. These guys do the vertical. If you didn't know that before, you better write it down. Y does the vertical stuff. Then, we want to do 1/2 and multiply by a negative. It seems like you multiply by negative 1/2. Can I trust the stuff on the outside? Yes. So therefore, I can just multiply all of these by negative 1/2. And I get negative 2 for this one. Multiply by negative 1/2. And I get negative 1 for this one. Multiply by negative 1/2. And I get negative 2 for that one. Multiply by negative 1/2. And I get negative 3. And multiply by negative 1/2. And I get negative 1. Do you get my new points? Would be this, comma this, this, comma this, this, comma this, this, comma this, and this, comma that. Do you get that way of doing it? That's the way I would recommend doing it on the test. Because if you freehand it and you make one little mistake, It's wrong. And it's really easy to just oops these. And like, oh, I moved it all down under and then I forgot that it was a flip. This is just a move. It wasn't supposed to be just a move. Your math is less likely to make those mistakes. So if you graph the points you get, then you'd be good. So what did I skip over that would be like way harder? The inside. Do you get if these changes had been on the inside, I would have to do them in the opposite in every way? Like it's the opposite of what you would think. So if there's a 2 on the inside, you actually don't multiply by 2. What would you multiply by? If there was a 2 on the inside, you'd multiply by 1/2. And if there's something that you're supposed to normally multiply first and then add, you would have to do the opposite. You'd have to do the opposite of everything, opposite of the order. Okay, so let's do those. Everybody find this right here, the M. And let's write down the original points, which are 0, 0. And 1, 4. And you shouldn't need me for this. Write down the rest of them. And then remember, it's on the inside. So does that mean we're going to mess with the X's or the Y's? Neil, what do you think on that one? The X's. And what do you think we're going to do to all the X's, Neil? We're going to multiply them all by 2. Why not 1/2? Because you don't trust the inside. Okay, so if I multiply all the X's by 2, I'm going to do that in red here. And I put all the answers in blue. 0, 2, 4, 6, 8. Now my new points, notice my y's didn't change at all, so it's still 0, 0. It's 2, 4. It's 0, 4. Sorry, 4, 0. It's 6, 4. And it's 8, 0. Do you get, as you look back on it, did it get taller? No. What did it get? Wider. Do you get it seemed like it should have been half as wide? So then it wasn't. It was twice as wide. All right. Now imagine for a moment that we did 2 things at once. Imagine for a moment I threw an extra, 1/2 on the front of it. You know, out in front of my f of x. What would that have done? We don't have to do it. We can just talk about what would that have done. Would I have trusted the 1/2? Yeah. And would I have multiplied all my x values by 1/2? No, not the x values. I would have multiplied all the y values by 1/2. All right. And then just think about what I would have done. Look, I can just do it really quick. Do. Do you get what I just did? I made it half as tall, but twice as wide as the original. Okay, so imagine you had this one. Everybody give this one a shot. Write down the original points. And let's make these changes. Who wants to do the easy part? Just get the easy part over with. Somebody volunteer and then I won't make you do the hard part. Okay. I've chosen Cal. What's the easy part?
Multiply the y's by -1,
All right. Why are you just trusting that you should do that?
because it's outside.
Yeah.
So you can just trust it.
Yep. Times by -1, it seems like what we should do, and you're right. And if I multiply them all by a negative, I get -4, -2, -4, -6, and -2. My y values are now complete. What's the harder part, Nick?
Set every x value equal to 1/2 x plus 5.
Nice. Set every x value equal to the stuff inside there. What? I thought I should multiply them all by 2 and subtract 5. Well, you're kind of right, but watch what happens when I set -7 is equal to 1/2 x plus 5. You end up doing it in the right order, see? Because some of you would have probably tried to double it first. Did you want to double it first? No. See, this is why you should set it equal to the inside, and it'll force you to follow the order of operations rules. And I will subtract the 5 first, and I get -12 equals 1/2 x. And then I will times both sides by 2, and I get what? -24. So this one is now -24. And you might be like, but that's way off the page. Yeah, it is. And that's okay. The key is, did you get -24? Who had -24 before I even said it? Okay, great. All right. Now if I take this -4 here. Again, can I try to do this in my head? Sure, you can. But just be aware, you're more likely to screw it up if you try to do it in your head. It's probably safer to go like this. And then I'm going to subtract 5 from both sides. And multiply both sides by 2. -18. Who had -18 before I said it? Okay, good. I think you get the idea. And then you just have to graph those points. You need to practice this. There are problems in the homework that will allow you to practice it. And we only practice things that are likely to be on your test. So obviously you need to know this, and pretty much everything I show you, it's going to come up on tests. So practice it. Practice makes perfect. And if you're not practicing, don't expect your test to go well. Yes?
I split the, inside into 2 steps, so I subtracted 5 from all the x's, and then I flipped the 1/2 and multiplied by 2.
There is more than one way to do this. Were you getting the right answers?
Yeah.
And that's fine. You know what the dangerous part is about doing it the way you did it? Is if you do it in the wrong order. You get what I mean? If you had first multiplied everything by 2 and then gone back and subtracted 5, it would have been the right two things, but in the wrong order, and you would have got the wrong answers. So just be really careful with that. All right, good. So that's the new stuff for today. Very soon I'll be introducing a lab where you're going to create a cool looking picture by moving functions around like this. So you did something like that in higher algebra, didn't you? Do you remember making like a, I don't know, some kind of a drawing?
Pumpkin.
Yeah, I think it was a pumpkin
I
project.
think we did it right around Halloween.
There you go. So this is, it was back, except it's more complicated, of course, because you're in pre-calc. But it's not incredibly bad at all. It's a pretty easy project. So it's a little project lab thing that'll be happening soon. All right, that's all I have for you. I'm going to look at the homework problems with you just to say, do you have to do all of these problems? No, but this would be a great reminder of how to move points. Definitely should practice that. Okay, and then this, it looks like they want me to take this function and move it. Oh yeah, that's right. Left 1 and down 1. Could you just take each dot and do that in your head? Sure. When they get to be more complicated shapes, you may want to list in an XY chart all the original points and then do that process I just showed you. And this is just reminding you how to write something like this. If I have the square root of x, but then I want to do right 2, minus 2, and down 3, the minus 3 has to be on the outside. There, I just wrote a function for it. That's all I mean. All right. Okay, that's all I got for you for today.